Welcome back to the Remdesivir Files, a COVID-19 chronicle. I'm your host Sowmya, and this is episode 2, COVID Strikes the Global Panic. Today, we rewind to early 2020, a time when uncertainty reigned. The novel coronavirus had just begun its rampage across continents. Nations were caught off guard, hospitals were overwhelmed, and the race to find effective treatments had begun. And suddenly, a shelled antiviral, remdesivir, re entered the global stage. To help us unpack this critical moment, I'm joined again by Saakshi Sharma, microbiology researcher who's been closely watching the evolution of infectious disease treatments for years. Thanks for being here again, Sakshi.
Always a pleasure, Soumya. These early pandemic days were unlike anything the scientific and medical community had ever experienced, even for those of us who had worked on past outbreaks. It was a truly unprecedented time, and remdesivir's reappearance is one of the most interesting pivot in the pandemic's early medical response.
Let's take listeners back to that moment, January and February of 2020. There's talk of a new pneumonia like virus in Wuhan, China. At that point, did the alarms really start ringing in the global scientific community?
Great question. In late December 2019, doctors in Wuhan reported a cluster of pneumonia cases with no known cause. By early January, the Chinese CDC had isolated a novel coronavirus, soon named SARS-CoV-2. And when they publicly shared the virus's genetic sequence on January 10th, the clock truly started ticking for researchers around the world. That's when the labs globally began analyzing the sequence to see how it compared to known virus and whether any existing drugs could work against it. The pandemic hadn't been declared yet, but among virologists and epidemiologists, there was already a growing sense of urgency. Many remembered how fast SARS and MERS has spread, and this virus had some worrying similarities.
It sounds like it was a scientific scramble. How did remdesivir come into this picture so quickly?
So, once the sequence was out, researchers noticed that SARS-CoV-2 shared a significant portion of its genome with the original SARS virus from 2003, over 80% similarity. That meant anything that had shown activity against SARS might be a starting point for SARS-CoV-2. Remdesivir had already shown promise in vitro, that is, in lab dishes, against SARS and MERS. In fact, in 2017 and 2018, studies from the NIH and other groups had demonstrated that it could reduce viral replication in animal models infected with MERS. That prior work made it a logical candidate for repurposing. So, even before we had clinical trials in motion, doctors began requesting remdesivir under what's known as compassionate use, especially for critically ill COVID-19 patients. There were no approved drugs. Ventilators were in short supply. In some cases, this was seen as a Hail Mary.
That term, compassionate use, is one we started hearing a lot. Can you explain what it really means and how it applies to remdesivir?
Absolutely. Compassionate use or expanded access allows physicians to use an investigational drug outside of a clinical trial when a patient is in a life threatening condition and no alternatives are available. In the case of remdesivir, Gilead Sciences had to review and approve each request individually. By late February 2020, the number of requests had grown so quickly that the company was overwhelmed. They temporarily paused the program to streamline it, and soon after, formal trials began under the guidance of organizations like the NIH and the WHO. These compassionate use cases were not controlled studies, but they began shaping the narrative. Media started reporting that patients who received remdesivir were improving. It gave people hope, but it also raised questions about evidence, access, and scalability.
And we were still so early in the pandemic. Borders were closing, lockdowns were starting. From a medical standpoint, how chaotic was this period?
It was incredibly chaotic. Hospitals in Wuhan were first to be overwhelmed, then Italy's health system buckled. By March, New York City was the global epicenter. Medical staff were working 20-hour shifts. ICU beds were scarce, and doctors had to improvise on the spot. In that kind of environment, the idea of an antiviral that would reduce the length or severity of illness was like gold. Even though remdesivir wasn't proven yet, it was the only drug with a somewhat plausible backstory, previous coronavirus activity, tolerable safety data, and some limited access. This is also when governments and pharmaceuticals companies began fast tracking everything trials, reviews, even manufacturing. It was a logistical nightmare, but also a marvel of coordination when it worked.
Were there any specific cases that pushed remdesivir further into the public eye?
Yes, one in particular stands out. In late January 2020, a man in Washington state became the first confirmed COVID-19 cases in the US. He was admitted to a hospital, and when his condition worsened, his doctor sought compassionate use of remdesivir. After receiving it, his condition reportedly improved within 24 hours. That case was published in the New England Journal of Medicine and received a lot of attention. It was just one patient, not a trial, but it was enough to build interest. From there, governments began negotiating with Gilead. Clinical trials started in China, then Europe, and then the US. We'll talk about those in detail in the next episode, but that early momentum came largely from these anecdotal recoveries.
We often hear that science is slow, yet here it seemed to be moving at lightning speed. How did the scientific community balance that urgency with the need for careful research?
That was a tightrope walk. On one hand, you had this global emergency with rising death tolls and no approved treatment. On the other hand, you had a molecule that looked promising but hadn't been tested in this exact setting. So the goal was to launch trials while also managing emergency use. To be fair, the scientific community moved incredibly fast. The NIH, for example, launched the Adaptive COVID-19 Treatment Trial, or ACTT-1, within weeks. Meanwhile, WHO was coordinating a multi-country solidarity trial. These were randomized control studies, the gold standard, but they were being designed and launched in record time. That balance was crucial.
It's remarkable. So, to close out this episode, what would you say was the key reason remdesivir captured the world's attention in those first chaotic months?
It was the combination of readiness, plausibility, and urgency. Unlike brand new drug development, which can take years, remdesivir already existed. We had enough data to suggest it might help, and in a crisis where doctors had little to offer, it represented a scientifically rational choice. But more than that, it symbolized the idea that science could fight back, that we were not totally powerless. It offered hope, however tentative, and in time of panic, that mattered deeply.
Beautifully said. Sakshi, thank you for walking us through this pivotal moment in the story of remdesivir and the world.
Thank you, Sowmya. It's a story worth remembering, not just for what we did right, but for the lessons we carry forward.
That wraps up episode 2 of the Remdesivir Files. In the next episode, we dive into the science of Remdesivir. If you're enjoying the series, do follow, share, and leave us a review. It really helps others discover this work. Until next time, stay safe and stay informed.